Hey there, everyone. Today, I want to look at the topic of price optimization, and we're going to compare that with overall attendance at a venue. Could be anything. Could be a sports venue. It could be a concert hall. Could even be a convention center, and the overall costs. Okay, so the concept here is based on economics. The less that you charge for tickets for entry to the venue, whatever it is, probably you're going to get more people going. As you charge more and more money, probably fewer and fewer people are going to go to that going to go to that spot, right? It could be City Field where the Mets play. It could be uh, in Midtown. What was that? Carnegie Hall. It could be anything, right? But as you charge less and less, probably more and more people will go. You'll fill all the seats, but you have fixed costs too, right? You have to cover your costs of operations, of cleanup, of the people checking the tickets at the front gate, things like this, right? So you have certain fixed costs that have to be met to open the doors and to keep the lights on and keep the heat on too. But if you charge too much, you're turning people away, right? So let's look at the concept and see how this works. So I put together a pretty basic model. We have a minimum price, maximum price. Okay, so these are the constraints. The model is going to make sure that the tickets for this event, whatever it is, it could be a bunch of different things. It's not more than 150, and it's not less than $15, right? The maximum attendance I'm setting here as 500. No, that is not City Field. This is going to be a smaller venue, probably Carnegie Hall, something like that. If you did have 25,000 seats in your City Field, then you would just adjust this parameter too. Okay, so that's how that works. I'll set that to 500. In this case, I think this is realistic for what I'm trying to do. I'm trying to make this model generic so you can take it and make these changes, right? And apply this to your own pricing optimization problem that you're trying to solve, right? I'm trying to make it generic enough that you can substitute this code for that and make a couple of very basic, simple changes here. But I'm also trying to make it specific enough so it's relevant and it answers the question of how to do this type of optimization, right? And there's plenty of reasons to do this, right? We want to try to find the optimal price point to adjust to market conditions. And this could be dynamic pricing too. I have a video on dynamic pricing. That's very interesting, kind of a different topic. But as more and more people want to do something, you see this in the hotel business, in the airline industry. Uber, Lyft does this too, right? As more and more people are using the service, the prices will jump up, and as fewer and fewer people use the service, the prices dip down, right? We can try to develop targeted promotions, maybe discounts, right, to stimulate demand, to get more people into the venue, and try to manage a long-term pricing strategy. We don't want to make this random. We could have our customers getting very angry at us if we have random prices jumping all over the place all the time, right? We want to have like a pretty consistent and pretty persistent type of pricing analytics here too. Okay, so we have the minimum price, the maximum price. I'm highlighting each one as we go here. The overall attendance, right? There's a sensitivity factor here. We have the min-max price, attendance sensitivity factor. This means how many people will drop off per dollar per dollar of increase in price, right? The fixed cost cover, the lights, the heat, the people checking your tickets when you go through the front gate, right? You'll have that, and variable costs per person. I'm saying this as 10. This is basically the cost per person attending, right? So as more and more people go to the place, it's going to increase your costs too, right? You'll have cleanup costs. You'll have some breakage, some wear and tear in the facility, things like that, right? So as more and more people go, it's going to cost you more to do your business. So we have to adjust for that as well, okay? So we have a few variable costs, a few fixed costs. Everything is going to be jammed into a data frame, right? We'll create the data frame right there and look at the results. So let me hit Control-Enter to run this. Okay, and we have the maximum attendance. Very simple math here. Prices minus the minimum price times the sensitivity factor. I described that above. Okay, so we have the array of data. Now let's go ahead and plot this. We want to find the optimal price row. Okay, so we're locating this in the data frame. The f.location ID max is going to show us the maximum price, and then we're going to have the optimal price and then the optimal profit. So pretty straightforward math here. Let me go ahead and run it. Optimal price is $60 and the optimal profit is $13,000. 700 and am I reading that? 13,735. Yeah, 13,735. Perfect. So we know the optimal price is 60. We don't have to guess. We don't have to charge 80 or 90 or 100 and scare off people, or even sometimes make our customers potentially angry. That could happen too, right? If the prices are too high, you see that a lot in grocery stores now. Grocery store prices are high everywhere you look. It's late in November here, 2024. So hopefully that changes in a few months. Maybe that will drop down. Who knows? Maybe they'll continue to go higher. But I know people literally that they're angry at the local grocery store. I don't think they have too much control, because I think their vendors and suppliers are charging more to do business now. Shipping, logistics, operations, it's just more expensive. Everything's more expensive, right? We're at least living in inflationary times. But the point of this exercise is to find the optimal price to generate customer satisfaction, right? Loyalty from our customers, build goodwill with our customers, right? So they know that the price isn't jumping around like the wind. Does the wind really jump? I mean, jumping around like moving around like the wind. That's what I meant to say. Sorry. Okay. So 60 is the optimal price, and you can see as we charge less and less, profits decrease, right? Because we still have the fixed costs. As we charge more and more, profits really tank over here on the right-hand side of this curve, because too many people are going to the venue. They're not going to attend the concert. They're not going to go to the ball game. They're just going to say no to all that, right? So $60, given these assumptions right here, and it's only a handful of things: max price, minimum price, sensitivity, fixed cost, and variable cost per person. You change these 1, 2, 3, 4, 5, 6 variables, and that's all you're going to have to do, and everything else is going to line up for you. Okay, so you can refine the model slightly by adjusting demand sensitivity, right? You can play around with that a little bit. You can include seasonality effects, right? Like in around the end of November, a lot of people travel to see family for Thanksgiving. Same's true for Christmas. You'll see seasonal factors, and certainly Amazon, Black Friday, people shopping around the holidays between Thanksgiving and Christmas. There's a lot of seasonal impact on sales, right? And you can also run sensitivity analysis or scenario analysis on the data and see what kind of changes that has, right? As you change the variables, the impact to the outcome is going to change concurrently, right? Okay, so I think that's it. I think that's covers the topic. Pretty simple, pretty straightforward. You can change those 6 variables and have that match your scenario, because I try to make all the videos kind of generic, right? So you can solve your specific problem, but it has to be specific enough to be able to answer the question. So I think we achieved both objectives here, made it generic and specific at the same time, so you can solve your own problem, whatever that is. Okay, I think that's pretty much it. Thank you so much for your time today. Enjoy the rest of your day. Goodbye, everybody.